Hello students of grade 11. Today we'll do exercise based on the types of relation. Before doing this, you have to know the types of relation very nicely, okay? So what is given here? A is 3, 5. B is 7, 11. Show that the relation A belong to A and B belong to B. A minus B is odd. Is an empty relation. We're going to prove that this is an empty relation from A to B. So when they say from A to B, find the cross product to get the relation. So relation will be, so it will be 3, 7, 3, 11, 5, 7, 5, 11. Now find out the relation whatever there. So only this is a cross product, okay? We are going to find the relation now. The condition of the relation is A minus B is odd. R is what? AB such that A belong to A, B belong to B, and A minus B is odd. Find out. If I subtract 3 minus 7 or 7 minus 3, we get even number, we get 4. If I subtract these two also, I get 8, even number. If I subtract these two, I get 2. If I subtract these two, that is also even number. If I subtract these two, I get 4. We get, oh sorry, I get 6. We're getting only the even number when you subtract the order pair. That means R is empty. So we can say therefore R is an empty relation. Clear? Hence proof. Let's do question number 2. If A is given as how much? 1, 2, 3, 4. And the relation R is already given. 1, 1, 1, 2, 2, 2, 2, 3, 2, 3, then 3, 3, 4, 4. We are going to prove that it is reflexive but neither symmetric nor transitive. So for reflexive, we have to see that 1 must relate to 1, 2 must relate to 2, 3 must relate to 3, and 4 must relate to 4. So we have this as 1, 1, 2, 2, 3, 3, and 4, 4 belongs to R, therefore R is reflexive. Let's check for symmetric, okay? For symmetric, you have to see that suppose 1, 2 is there, 2, 1 is there or not, you have to check. If one element is also missing, that means it's not reflexive. So I can say 1, 2 belong to 1, 2 belong to R. But check whether 2R implies 2R belong to R or not. Is there any 2, 1 belong to R? Is there any 2, 1 here? No. 2, 1 does not belong to R. That means it is not symmetric. Let's go for transitive. Transitive, what is transitive? For transitive, we have to know that A must relate to B and B must relate to C, implies A must relate to C, something like that, okay? So we'll use this only. We can say that here 1, 2 belong to R and 2, 3, I'm using this only, 2, 3 belong to R. Does it implies 1, 3 belong to R? we have to see these two is related or not. 1 3, does it belong to R? Does not belong to R. 1 3 is not there. So we can say that if one condition is also not satisfied, we can say that it is not transitive. Okay, so we can say that therefore it is not transitive. Let's go to question number 3. Show that the relation R in the set A, suppose A is not given but 1 2 3 given by R is 1 2 and 2 1, is symmetric but neither reflexive nor transitive. They have given, I'll just write A first. A is 1 2 3 and the R is 1 2 2 1. So we'll check, does 1 1 2 2 and 3 3 belong to R? Does 1 relate to 1 and 2 2 3 3? Does it belong to R? No, it does not belong to R, so it is not reflexive. Okay, now 1 2 belong to R implies the opposite also is there. 2 1 belong to R. That means it's satisfying the symmetric property. It is symmetric relation. Okay, let's see the third condition. 1 2 belong to R and 2 1 also belong to R. Does this one first and the last belong to R? But 1 1 does not belong to R. Therefore it is not transitive. Clear? Please write the question also, the solution also. Let's go to question number 4. They have given A equal to, I forgot to write this, A is A, B, C and R is also given. I wrote as it is. We are going to prove is reflexive, symmetric and transitive or not. Not proof, we are going to check whether it is reflexive, transitive or symmetric. For reflexive, we have to have AA, BB, CC. So AA we have, BB we have, CC we have. So S, AA and BB and CC belongs to R. It is reflexive relation. Okay, let's go for symmetric. Just for if one element is also not satisfied, that means it's not symmetric. Okay, we have AC, we have CA, we have AB. Do you have BA? We can say that AB belong to R. Does it implies BA belong to R? Does not belong to R. BA is missing here. AB is in R but BA is not there. That means it is not symmetric. If one condition is also not satisfied, that it is not symmetric. Okay, let's go to the third one. We can say that BC belong to R. See, BC is in R and CA also belong to R. CA also belong to R. Does it implies BA, this first and the last element belong to but BA does not belong to R. BA is not there. That means it is not transitive. Clear? Let's go to question number 5. Show that the relation greater than on the set of natural number is transitive. Is transitive, but neither reflexive nor symmetric. So, set of natural number means it will be 1, 2, 3, 4 and goes on like that. And the relation R is given as you have to see greater than, okay. I'll just use xy such that x greater than y you have to check this relation x greater than y, okay. So to check this relation, let's check first it is reflexive or not. Checking for so x related to y implies what? X, when you say x related to y, condition is it must be x is greater than y, okay. But for reflexive we have to use the same number. X related to x, is it greater than x, can be greater than x, which is not true. The same number cannot be greater than itself, okay. Therefore R is not reflexive. Clear? Let's check for symmetric. So for symmetric I need two elements, x related to y implies what? X is greater than y. Does it means that y related to x, y will be greater than x? Is it possible? Which is not possible. That means it is not symmetric also. You can use the number is also 5 greater than 6 and 6 greater than 5, which is not possible. Oh sorry, 5 greater than 4, and I'm using 4 greater than 5, which is never possible, okay. That's why it cannot be symmetric. Next is transitive. Let's check for transitive. X relate to y, let implies what? X is greater than y, and y relate to z. Suppose the third element comes in transitive, implies y is greater than z. Then if I take the relation x to z, x related to z, is it possible that x is greater than y? Z? Yes, it is true. Suppose x is greater than y, and y is greater than z, that means x will be greater than z when you compare. So I can give a simple example. 5 is greater than 6, and 6 is 5 I am saying. 5 is greater than 4, and then we are using by 4 is greater than 3, that means automatically 5 is greater than 3. This condition is satisfying, that's why we can say that it is transitive. Clear? You can pause the video to write the solution. Thank you.